Now I'll invite Oleg Solontsov to take his place in the podium, and now we'll have pleasure to hear the report on the usage of remote sensing data for governmental forest inventory.
Dear colleagues, we use space images not only for forest management and forest inventory under the forest code that took effect in 2007. Besides, we're using this data for placing forests on the cadastre of immovable property or real estate. During the forest inventory, remote sensing data is used in two ways. First, to determine quantitative and qualitative characteristics of forest, and remote monitoring of forest to detect illegal logging or unauthorized use of forest. During the forest inventory, we rely on 2-meter images from who's responsible for the playback? Yep, we're there. The total area requested for capture last year was around 180 million hectares. The bulk of it fell for WorldView 1, WorldView 2, and QuickBird, and other satellites were utilized as well. In 2012, the contract with the Federal Agency of Forest Management, so we covered about 125 million hectares, and the distribution, the breakdown is basically the same, WorldView 1 and QuickBird and GeoEye. This year we used a little bit from Spot 5 and from RapidEye. The workflow to determine quantitative and qualitative characteristics of forest relies on forest management materials. You all know that forest management in Russia has been developing for over 200 years, and the whole of the territory has been covered by at least one of 4 methods of forest management. First, the creation of digital bases, then updating digital bases for economic activities, human impact and natural impacts based on remote sensing data, statistical determination of location based on coordinates of permanent testing grounds, further updating of schemes and maps for forest strata, but not for the whole of the country at the moment, and the comprehensive processing of stratification data to determine qualitative and quantitative characteristics. The main materials of space-borne imagery used in 2010 and 2011 differ somewhat in terms of satellites used. In 2011, there was an increasing share of RapidEye acquisitions, and there is a declining trend in terms of resolution. This year, most of the coverage uses 2.5 plus resolution. Until 2010, we used the spatial resolution under 10 meters, in 2010 under 5 meters, and 2011, 2012 2.5 and better resolution. One of the ways to amend the forest inventory materials is the visual comparison of space materials with the available forest maps, which show all the activities that have been carried out in the forest. I mean planting, seeding, wood cutting. Then by comparing the forest tablets and space imagery, we can reflect additions that have been made or any changes that occurred because of, for example, logging. Another way of change detection, which we utilize quite extensively, are synthesized images taken from different times. If there is no mapping available for a selected year, we use aerial photography. You know that in the production flow of forest management, we always relied on aerial photography in rather high resolution to detect and predict negative impacts on the forest. We perform remote monitoring of forest. This is the updated scheme of forest strata with areas for each stratum. And this is a test platform, test plot. It represents a few circles where measurements are taken of trees of different size, different diameter of the trunk. Heights are checked with 50 centimeter accuracy. We also track reforestation, afforestation, the total of 120 parameters. Over 8 years of existence of the second type of forest management cadastre, where space imagery is born, it has proven to be quite effective in the eyes of wood harvesters. It's also useful for mining, for gas industry. In 2012, we are operating on the area of 100 million. I'm talking about 33 subjects and 156 forestry enterprises. So what we do first is analyze raw data for the site. We check logging data. Then we look at the available maps. We do interpretation. We detect infractions that have been detected. Then we selectively verify the results of interpretation of aerial photography materials. When it comes to selection of forestries for verification, we look at the areas where cutting activities are very intensive, and there are two criteria used. If the ratio of timber harvesting per 1 hectare is over 3/10, and if it increases 10,000 cubic meters. We are talking about 400 million hectares from northwest of the country to the far east. Like I said, this year we are covering 100 million, but every year there is a rotation of objects. This year we have 35 new objects that have never been covered with remote monitoring. The number of subjects in the Russian Federation is 33. The number of foresters is 156. The number of monitoring sites is around 100 million. We use satellites, rapid eye predominantly, then a little bit of rapid eye in 2012. As of September 1st, 95 million hectares have been captured by WorldView, and these are the same images that we used in 2011. Their quality is quite okay. The workflow for remote monitoring of forest use includes vector layer of infractions, vector layer of cutting areas, vector layer of grid, of quadrant network. The yellow color shows the cutting area, and the red color shows where the cutting was not allowed, but the red on the right shows the area where there was illegal logging. This is an example of creating a multi-temporal composite using panchromatic pictures from Spot 5 and WorldView. In some areas we relied on radar imagery because the northwestern part of the country is not properly covered optically, and we believe that the radar imagery is something that we will have to rely on in the future, especially when it comes to detecting changes in the forest cover. And what are the prospects? We are doing a pilot project on continuous monitoring of forest use in near real time. We're also working on creating a geoportal of forest register, which will allow us to merge the available information. We are very cautious about using multispectral images, and we continue to consider using radar imagery on wider areas than before. That's all. Thank you. Dear colleagues, we are behind the schedule, so I think it was a very informative presentation. If you have any questions, you can ask those later. Thanks.